Okay, good day. So on this video, straight to the point. On this video, I'm just gonna try explain the what is the thing called algorithm analysis, right? Runtime counting and stuff like that. So I'm just going to explain the examples given in the slides, right, for better understanding, since you supposed to use them at the end of the day. And then thereafter I'll use the same question that I solved when I was using my the third year tactics, or I'll solve it using the how they solve it, how they solve such questions on the slides, right? So yeah, right away we have an example one over here. It's about constant time algorithms, right? Constant time of one, right? So they say, suppose we wish to find the running time of the following C++ code, right? And then this is the code, right? Yeah, yeah, this is the code. And then on the next slide, right? That's why they're solving these lines of code here. That's why they started doing the counting, right? And as I said before, that in each and every counting that you're going to be doing, you must have a list of your assumptions, right? Or an assumption statement or something, right? Something like this over here, right? So here they tell you that they're going to be counting using these operations over here, where you see a plus sign, an equal sign, and this one here, it's an or, right? I believe, right? Then that's where you're gonna count those things, and as constant time. Constant time is O of 1, right? And then each operation takes the same amount, that's fine. And then whatever. So like even if even in your answering, like when you answer such question, you can just write assume, and then you write your statements there, or your operations or your conditions there for you to count, that you're gonna use to count, right? Yeah, so they know that what you have used in your accounting, when you're accounting or in your analysis, something like that. And then even you can even do this, let it be the runtime of the algorithm. Since you don't have to do this part over here, I bit disagree with it, right? But then I realized that you guys in your code, they don't show lines where you can say line 1, it's because it is constant time, line 2, it's because it is big or something like that. So it seems as though you're just supposed to calculate everything in the one go or something like that, right? But the way I would prefer is using the lines. So we'll see how to answer the paper that I gave, or well, the question that I have at the moment, right? So here, as you can see now, that's where the counties are. But again, yeah, the counties are that they're saying 10 is an equal sum of operation along whatsoever. Part 1 plus 1. Where did they take these things over here? So as they said over here, that they're gonna be counting using this. When you see a plus sign, and then when you see a equal sign, and when you see an or sign, you count those things, right? Already here you see an equal sign, right? They didn't include a declaration. I did say that it depends on the assumption. On, I think now on the example or question I did, I also included the declaration, where if you were to include the declaration, it would be 1 for declaration of A, and then 2 for the assignment or using the equal sign, right? So it'll be 2 for me on this line. But then since here they didn't include any declaration as part of the counting or as assumptions, they're only doing the equal sign, therefore it's 1. So the 1 comes from here, it's going to be 1 plus 1 plus 1 plus 1 plus 1, right? So over here you already have 5, which is this part over here, right? I hope that makes sense. And then the 3 and 4, I think they made a mistake. Why am I saying that? Because the 3, well, on the or part, I'm only seeing these 2, right? So it's supposed to be 2. I don't know where they took this 3. I don't know if it's a mistake or maybe I'm missing something here, right? Also here is we have 1, which is the equal sign, then 2 and 3, right, for the operations. So here they search for, I don't know where they took the 4 and how they or how they took the 4. That is just two things that confuse me on this slide. But otherwise, for me, this would be 2, this would be 3, and then the total would be minus 2, 10, right? Yeah, that would be the 10, and then the T of or working or big O of n, or no, big O of t will be O of 1 constant time, right? That will be the answer for this thing. That's how you're going to answer this thing. Again, it depends on your assumptions. So far, you do know already you have to include the plus sign, the equal sign, and the odd sign. That should be one of your assumptions. I figured that you instead of having to ask, you can just take the examples of assumptions they used in the slides, just use them all together, right? Well, depending on the given code, if it doesn't have, for example, this part, the or inside, you don't have to include or in your assumptions. You only include the things that are there in the code. For example, they didn't include what the less than's and whatsoever because they're not there in the part of the code. So you don't have to include them. Only the things that are there in the code, you can include them. And then let's move to an example 2. You'll see what I mean. Right, we have this code over here. It has an equal sign, less than, or the yeah, these things over here, the comparing signs. And we also have and you also have not over here, right? And then you also have array indexing over here, right? The square brackets. And then you have the comparison again over here. And then this one, and then you have plus plus, right? In the example, the question I solved, what is it? I simplified this, right? Here they didn't simplify it. Instead, when they were given the assumption, they said they will count using the equal sign, which is normal, and then the less than, which is this sign over here, right? And then the end, and then which is this one over here, and then the not, which is the one over here, right? And then the double equal sign, and then which is the one over here. Oh, the indexing, array indexing is this one here, right? And then this one, they counted as 1. They didn't have to simplify and say this is the same as I, it's equals to I plus 1. Therefore, it's going to have assignment and operation there. No, they just took this one as 1. So it's doable like that. Hence, yeah, what they said over here. So this will be your assumption, right? And then you can say assume, and then you write the things that you're gonna use to count, and then you also write this one and represent the problem size that this is important, right? You tell them like yeah, and then let and okay, you can use this also, let n or and from there you count, doing your counting and stuff like that. And when you're done, then you determine your peak of n or your BigO, right? So yeah, let's count this and see how much they'll give us. Let's assume now you wrote this statement, two statements over here. Like each operation takes the same amount of time. I mean, you can also write this. There's nothing wrong with that. Like up until here. And then from there you start with your calculations over here. So it's gonna be T of and it's equals to, right? We come back over here. So we have 1 and 2, right? We are 1 and 1, right? Assignment and assignment. Don't get confused. Therefore, it's 2, right? Yeah, therefore is 2, and then hence the 2 over, wait, hence this 2 they did mention here. Total number of operations outside the loop. Here is the 2, right? And then in here, what they did, how they did it here, I don't like how they did. Rather just do line by line, because here you can say on this line here, there are things are happening here. We have the less than, right? 1, we have the end 3, I mean 2, and then we have the not, which is 3, right? Funny enough, these conditions will be called n times. Why? Because it's a while loop, right? Hence, it's supposed to be what? 3n over here, right? So you have 2, you have 3n over here, sharp. And then you come here. Here you have, maybe I'm gonna, I don't know if there's paint. Can I draw at least? Let's see. I can't. No, I can't draw anything. Oh, I can actually. And then let's see. So here we're gonna have three. Yeah, okay, that's not giving. It's gonna be enough. Okay, that's better. So how do I remove this now? My word. Okay. Oh, okay, that's better. Anyways, so like I said, we have one over here, we have one over here, right? Together is two. And here we have three, right? And as I said, since this thing would be called three times, this condition will run n, not three times, n times, since it's a while loop, and it's running from I until I is like no longer less than array length, right? So it's gonna run n times. So we have 3n over here, right? That's fine. We come here. So we have this line up here, we have array indexing, which is 1, and then the double equal sign, right? The comparison, which is 2. So you're going to have what? 2, right? But then this thing will run n times also because it's inside a while loop, which is something I missed when I was answering the question that I sent in the group. So it's something I missed, that when you're inside the while loop, you, as much as these things over here, this line, it has two things, but then since it's inside the while loop or for loop, it's gonna run n times, right? Because obviously each and every time when it runs, this line will be executed. So this will be 2n, right? And then here we have only one thing, but then obviously it's inside the while loop, so it's going to be 1n. And then also here, it's going to be run, it's going to run 1 times, but then it's going to be what? 1n, right? I hope it makes sense. So in total, we're going to have the addition of all those 1n, 1n, 1n. I mean, 1n plus 1n is 2. And then 2n plus 2n is 4n. 4n plus 3n is 7n, right? 7n, and then plus the 2 there at the top. Yo, that is not good. Plus the 2. So something along these lines. I hope that made sense, right? And then again, this all everything here depends on your what assumptions. Maybe if it didn't include anything, like if it didn't include maybe for example the not over here, you would have not counted it here. Therefore, here it would have been just 2n. So everything depends on your assumptions for you to do the thing. And there's no one right answer, because you can, you know, a student, you can have like different assumptions and stuff. But I suggest that you just look at the code you're given and then pinpoint the things that you can use to count. Right? That is way much better. So yeah, hence the answer here, 7n plus 2, right? And then to the big O of this thing is O of n, right? Because yeah, O of n, hence the answer over here. This is also important. After determining this, you're supposed to say, therefore the, what is it? Therefore, O, my bad, is using a mouse to, O of t is equals to O of n, right? When you're done, like you get the point, O of n, O of t, right? O of t, O of this t over here, it's equals to O of n. Yeah. Anyways, that's it for that example. And then this one over here, of which I also find some errors, but we'll look into it. So we have what this code we're given, and then we have assignment. So already you just look at the code, and then you think of the assumption or of the conditions you're going to use to count, right? So you're gonna use the assignment, you're gonna use the less than or the comparing, the plus plus will count as 1, right? Same applies to here, nothing changed. Same applies to here, nothing changed. So you're only gonna be using the equal sign, the less than, the plus plus, right? Hence these conditions over here, right? The operations are a fair measure of complexity and whatsoever. Again, you can just do this part, like this part, you can just copy it as it is. Obviously, this will change, these operations will change over here, right? Yeah. But then from here to here, you can just write as it is. And then when it comes to obviously determining, it might be different. T of n, then let's start the counting. We have 1, 2, 3 outside, right? Hence this 3 over here, or they even said it over here. Hence this 3 over here. That's fine. And then here, right, they did something different over here. Of which one thing I believe is wrong. Here they said the outer loop, right, is this one over here. It's equals to inner loop multiplied by number of loops. Oh, nope, that is not make sure. Outer loop is equals to inner loop. No. Loop plus both. Yeah, the way they count is not make sure here. I don't quite understand, but what they're doing here, they're starting with the inner loop, right? They're saying loop header, which is 3 things, and then plus loop body, which is 1. If you look at the inner loop is this one over here, right? And then the 3, where did they take it? Where did they take it? They took it from take it English from these things over here. That's where they got the 3n. And then the 1, this one, loop body equals to 1. They took it from here, since this is counted as 1. And then hence these things are inside the loop though. They're inside but then these ones are inside a loop, so they're gonna no, okay, the way that they use this thing I don't understand. Let's use the way I was gonna do it, and I'll explain why this thing is not right, because they also counted this thing over here, right? And then like I said, the initialization of a variable in the for loop header only happens once. I don't know why they made it part of like the n running time, so which is the mistake I found. But nevertheless, let's just use the way I was gonna do this. The answers will be different, by the way. So here, right, let's see, this one for me, this one here for me will only run once, right? Once when the for loop is called, right? It will only execute once, and that's it. And then the 2 over here will execute n times, yes. So it's gonna be n times, and then over here it's gonna be n times, right? Beside that, you know, this is 1, right? Counted as 1 multiplied by n is n, and then this is 1 multiplied by n is n, right? So here for me on this line here, we're gonna have 2 n plus 1 plus 1. Why? Because the r equals to o happens once and once only, right? So you can't say it's the and when it happens once. They are not like terms, mathematics, right? So this is what I was gonna do, me personally, right? That's why we come here now. You'd be done with like the thing, like 1 comes from this part over here, because it happens once, and you have the equal sign, and equal sign is part of our operations we use to count, right? And then here you have the less than and the RR. This is 1, this is 1, yes, but then it's gonna they're gonna execute n times, because when the for loop runs like for the first time, it comes and compare. When it comes again, it comes and compare. When the third time, it comes and compare up until n times, right? So it's gonna run n times. Same applies to this one. When when the loop is about to end, it increments, go to the next value up until the n value, right? Hence n times. So I hope that makes sense, right? And then this one is only gonna run 1 time when the loop is called. Initialize to 0 only once, and that's it. That's my point. And then now that we're done with that, on this line over here, same applies. This will execute only once, right? This will only execute once, and this two will execute n times, right? N times over here. Sharp. So we're gonna have here, we're gonna also have the same thing, 2 plus 2n plus 1. But here's the trick about this one, right? This one is also, it's happening inside a for loop, and that for loop runs how many times? N times. So the whole thing over here is going to be multiplied by n. I hope that makes sense. Why is that? Because this for loop, this inner for loop here will be executed n times as the outer for loop will be running n times. I hope that makes sense. And maybe just to simplify, this will be 2n squared and then plus n, right? To excuse my ish, not nice trying to write with the mouse over here, plus n, right? Hope that makes sense. So now we have that, and then we have this one over here, which will just be running one time, right? That's fine. But then again, it's running inside two for loops, this one and this one. Therefore, and the two for loops together is n squared, because this one is n, this one is n. So it's going to be 1 multiplied by n squared, which is just n squared, right? Then that will be it over here. So your counting will be n squared, right, plus this over here. Let's see, let's change the color. When you count, it will be n squared, right, plus this over here, plus this, and then plus the array over here. This is the array, by the way, right? This all these things over here is the array, the total of the array. So I'll just write the array over here, right? So the answer, or your Tn ish, yeah, it's not nice, eh? Your Tn will be something like n squared plus 2n squared. That would be 3n squared, right? And I think if after I'm done here, then we'll do the question in the paper, and then we're done with the n squared. Then we have n plus 2n, which will be 3n, and then 1 plus 3, which will be 4, right? So this would be a T of n. And then your big O of T would be T, or would be working O of n squared. Big O of T or O of T would be big O of n squared, right? I think regardless of the calculations you get, the big O, you should always get it right, because there's only one answer to big O. You can't have O of n over here, or O of another thing, log n or whatsoever, of which you guys are not doing them. You're not doing log n or anything. So the only thing that you're doing is O of 1, O of n, and O of n squared, right? So yeah, this would be my answer. You see, so you can see it's different from what is given here, right? Because of the reasons I gave when I was explaining, which I don't understand why they did that. But yeah, that is that. The aim also is to make you guys understand, right? Otherwise, like I said, everything depends on your assumptions or the operations you use for counting, right? Everything depends on that. And then from there, the big O, like I said, it's always this one answer. You can't have a different answer over here. They might be different, yes, depending on what the student use as assumptions whatsoever, right? So like, to answer the question, or to tackle the question which I did yesterday, and I found that I was actually making some mistake here and there. Let us see the question. So it was given like this, right? Can I add paint or something over here? I wonder. So I don't have to. Well, okay, but then I had the notepad actually. Let me do this. Let's see. Do I agree? No. That. Wait, what? Okay. Yeah, so we have something like this, right? And then these were the answers that I gave you guys, but I'm gonna rectify them here and there, right? Okay, so like I said, the best thing to do, you can start by writing your assumptions there at the top. Assume just exactly as they did it in the slides, and then you just let me just copy and paste, because yeah, that's the way to go. No, okay, can I just okay. This is not going to work. So let's see. That's fine. Assume. So I'm just going to copy them. Okay. Just going to copy from here to here, and here, and paste this. Right. So each aurora 100%. Then this can come a bit over here, and then let whatever the TN. Anyway, so something like this. Obviously, this will change. We're not going to, or not all of them actually. We do have the equal sign, the less than, and then the plus plus. We do have that. So we're just gonna leave that as like that. And then here we can also add the dot here to show what it counts, and then also the what, the square brackets, right? Yeah. So if I were to do that now, would it be 1 and 2? Because that's array indexing, or should I just double and then count them as one? So it also depends on you, eh? Yeah, it also depends on because it is array indexing, but then if you do one bracket, that means you're gonna count one for each over here, and then if you do two, then you might just count the two as one, right? I hope it makes sense. So I don't know, for the sake of this, let me just use one, right? Therefore, when I compare, it's going to be 1 and 2 because this is different array indexing. This is the rows, this is the columns. And then, yeah, and then the dot, and then the assignment is there. Then, yeah, that's it. And then the return type, the return, and then also return. You're also going to count it, right? Yeah. So once you've done this, then you go and then you come here. Again, you guys don't have lines here, but the lines, if you still recall, I on the picture I said I did show, I did just draw some imaginary lines for myself and for you guys to see what's happening. So basically line one was this one, the outer for loop. Line two was the inner for loop, the header, and then 3, 4, 5 were this one over here, 1, 2, 4, 3, 4, 5, and then the 6 was the return. So I skipped the spaces, the lines over here, just went straight to here. Hope it won't confuse you. Anyway, let's start. So here I'm gonna have, based on the assumptions over here, right? On the outer for loop, on the header, we have one, which like I said, it only happens once. Mind you, I'm not counting for declaration over here. If you were counting declaration, or if you want to count declaration, you can here and you write declaration, right, as part of your counting, for example. So since I'm not counting declaration, I'm only gonna count the assignment. So it's gonna be 1, right? And also less than and r plus plus, which will happen n times. So this will be 2 plus 2n, 2n plus 1. What am I doing? 2n plus 1, right? That's fine. And then here the same thing will be 2n plus 1, but then it's happening inside a for loop, right? And then that for loop runs n times, hence you see the n over here. And if you simplify this, you're gonna have 2n squared plus n plus n, right? And then over here, the mistake I did was that I was saying n squared plus 2. It's supposed to be 2 multiplied by n squared, or n squared multiplied by 2, right? Why am I saying that? Because actually it's gonna change now. Let it change actually. Line 3, which is this one over here, by the way, right? We have assignment, which is 1. We have dot, which is the function call, the array, and then we have indexing, right? 1, 2 indexing. So we have 4, right? 1, 2, 3, 4, right? On a single line. Therefore, it's gonna be 4, and then this thing will happen on like it happens inside the two for loops, which is n squared. So it's 4 n squared. That's a mistake I was making, right? So it's gonna be the same for line 4 and line 5, right? Because they both have the similar code, lines of code, right? The assignment, call it the working, the dot function over here, dot method, and then the indexing here, right? And then the return is just 1, nothing changes there. So, but obviously the formula here will change because it's 4, 8, 12, and then plus 2, which is 16, 14, 4, 8, 12, 14 actually, not 16, right? And then here we're gonna have 2n plus n, which will be 3n, no longer 5, right? And then we're gonna have what over here? We're gonna have 1, wait, where did I get the 9? Well, oh yeah, because I was adding. So we're gonna have 1 plus 1 over here, which will be 2. And then the big O doesn't change, it's still n O of n squared, right? So only the calculation changed based on the assumptions I gave over here at the top, right? That's how you solve the question. I hope this helps some of you guys. And yeah, if you still have any question related to this, you can send up the group and I'll try to attend it. Otherwise, shout out.